this is Eric Calvitis and Ben Plower from Anderson Global. In this video, we're going to go over DFM, or Design for Manufacturing. Ben, looks like you have an example pulled up. Can you kind of go through the process and let us know what you look for in a casting, adjustments that might need to be made, anything along those lines?
Sure. A casting comes in. A lot of times the designer designing the casting itself doesn't really necessarily understand what standard foundry practices will be. A lot of times draft and wall thicknesses and things are not really thought of up front in their level. When we get it, we have to go through, analyze it for draft analysis, wall thickness, to determine which specific casting process it's going to be used, might determine some of that. But in general, I can just kind of walk down through here. You can see there's a manifold. The file came in directly like this from the customer. So the first thing that I do, I open it up, kind of roll it around, start analyzing it. I'll look for the first thing is we'll go through and look at a draft analysis. So when I go through, for example, if I'm going to be using this in permanent mold, the draft that we typically like to see is 3 degrees minimum draft. So as you can see, as you bounce around, I set my scale over here at plus and minus 3. So anything that is this magenta color is going to be able to have 3 degrees in this direction, and anything that's the blue direction will have 3 degrees in this direction here.
So anything pink and blue are kind of good, right?
Yeah. So anything that you see here that's green, I have to look at and I have to address how we're going to handle that. Sometimes, as I'm going through, obviously I will look to see if I can alter the casting shape and geometry for the most simplest solution, which, typically if I can go in and I can modify the graph so that we can have a standard open and closed mold, that's better. Now, there's some situations, like you can see over here, there's going to be a combination of both. I can already see, like over here, there's going to require an additional core that's so I can capture and maintain this shape. But in general, as I walk around, that's what I'm going to look for first.
Okay. So sometimes when we receive a casting, it's basically at a point where it's been designed for fit and function, but not necessarily for the actual casting manufacturing process that it's going to get made in, right? That's
correct. As people get more and more experience and understand the foundry requirements, but there's still many castings we get that we need to go through and adjust things on. So as you can see with this one, there would be quite a few things that I would have to go through and modify. And I'll go through I'll show you the wall thickness check on this specific casting and what I look for on that, and I'll open up where the final of this particular casting ended up, and I can kind of walk through that one too. Now that I've looked at it for draft, the next thing that I want to do is I want to check out wall thickness. What we're looking for specifically is an aluminum casting. What we want to look for is uniform wall thicknesses, just to, in thin sections, thick sections, all of that stuff has an effect on how the casting is going to solidify. So the first thing that I'll open up, I'm going to look for some thin walls. I'm going to have my minimum wall thickness on this casting is 1/4 inch. So I'm going to set my range so that it picks that up. I can go down through and I can see where, right here is a slight thin area that I might need to be concerned with, that it's not at least 1/4 inch. It may or may not be an issue, but at least it kind of highlights it and shows me where I'm at. And a couple of areas up here, same deal. So once I understand if I have any thin wall sections, it doesn't seem to be too bad. I look pretty good. I'm going to go in and I'm going to adjust this to see if I can pick up any thick sections. So what I do is I can adjust my scale here. So when I adjust my scale, anything that was yellow was a consistent wall thickness before, but where you can see these blue areas now that jumped out means that there's thicker than this 10 millimeters or roughly the 3/8, which, when you start to run your solidification, the heavy sections are the ones that are you need to be able to feed them or eliminate material to figure out how to feed those so that you can get a good solidified casting.
Okay, so this process really you're trying to maintain kind of the general interface of the original casting, but you're also worried about the function of the mold and the solidification of the casting.
Right? It doesn't do me any good to just make a mold of this specific casting, because you're going to end up with some shrinkage in these areas if we can't feed them. So that being said, then that's the basics around the DFM, or for those couple ones. I'll open up where this specific model ended up and just kind of walk through the same process. First thing, we'll turn on the draft analysis here. So I can go ahead and I set my scale at that plus or minus the 3 degrees. And as you can walk around, you can see how all of these colors now are specifically the magenta for all of it is in this one half of the mold here. If you come around and you get a nice blue all the way around. So you can see that when we went through, it's drafted for permanent mold now.
And it looks like there's some areas of green kind of on the left there. Was that on purpose or?
So this is the area that I had discussed earlier, right? Where we needed to keep and maintain this shape. The only way to get this, if you didn't want to have a core, would be to load this up all the way to the parting line. Well, it's not functionally wise, that's not what anybody wants. It adds a lot more mass to the casting, and so this one did require a core in this area. Now, what we would do is I would check the draft in a different direction just to make sure, as you can see here, right? I just changed the orientation of that so you can see how that would all pull from one direction. We would add a core that was set down inside of the permanent mold in this specific area to create that shape and get the undercuts.
Okay, yep, no, that makes sense.
Now that my draft is good, and I want to take a look at a wall thickness. And I'll run through the same deal that we did before. So you can see I've got my minimum wall thickness is set at the 1/4 inch. So as I go around, I want to look to make sure that everything's at least that the blue area and above. It tells me that my wall thickness is going to be a minimum of the 1/4 inch, right? So as I look at that, you can see where we had a couple areas we had over here, and there was another one, I believe, right over here. Anyways, we went through and purposely adjusted the shapes to allow a nice consistent wall thickness. Now, knowing that, we also, you can see on the inside here, we took out material. We were struggling with some of the solidification results on the inside here. So we also went through and adjusted, for the thick sections. So as you can see now, when we walk around, you can see where we had seen those nice thick lines that you were seeing here. They were going all the way up through the shape here. Okay. Now we were able to remove the material and consistent wall thickness over all of these areas here for these, but we couldn't get rid of it down here just because of the shape of the tool and the design. But what that tells me now is I did get it close enough to this edge here where I can then feed those larger areas with risers and things like that. Or if I need to with cooling inserts, I can adjust it. But when I have large areas that go into deeper sections into the casting, it's more difficult to feed those. So that's why we would start to remove and make those wall thicknesses nice and consistent.
Okay, so at the end, it's a very similar looking casting from a kind of a distant view, but as you get up close, there's a lot of small tweaks that make it better for the process and kind of more of a proper casting for
anything that is going to be machined. We also, what we would do is we carry this over into the machine model. We would ensure that anything that we had done doesn't affect any of the other of the functionality of that part, right? So as you can see, it's very similar. The profiles where things would mount to are all the same. So we didn't change any of that, but we did a couple things. We removed some mass from the casting, but it also made it where it was much easier to cast as a part.
All right. Well, that looked like a good example, and thanks for showcasing the DFM process. All right. Well, those of you who are interested in contacting us, at the end of this video, there's going to be an email and a phone number, and also a button to subscribe. Thank you for your time, Ben.
Thanks, Eric.